There's a question about some of these problems that have ropes that have mass. So here's one from the book. This is chapter 7, exercise 13, I believe. And you're given two blocks, A and B, that are mass 1 kilogram, and two ropes that have a mass of 0.25 kilogram. So the trick here is that you essentially just treat the ropes like they're another object. All right, and so you're told that the acceleration of the whole system is 3 meters per second. And so when you have problems like this, the first step with multi-object problems is usually trying to group all the problems together in one clump. That gets rid of any internal forces. And so right here, if I look at all the objects together, it's a mass of 2.5 kilograms. So I'll call that MT for mass total. And if you look at them all together, the only forces, there's a force F upwards, and then there's mass total G downwards. And the other force acting is going to be an internal force, and because of Newton's third law, it would cancel out. And so if we look here, we do Fy equals MTA. So it's Newton's second law in the y direction. The forces acting would be the upwards force, and then minus mtg equals mta. So we're solving for the force. We do that. We get mtg plus mta. And so if I pull the mt out, I get mtg plus a. And this is going to be a common thing in this problem. G is 9.8, a is 3. So when you add those together, you get 12.8 meters per second squared. The mass is 2.5. When I figure this out, I get that upwards force should be 32 newtons. Now in part B, they want you to find the tension at this point right here, sort of the top of the first rope. All right, and the easiest way to do that is to cut the problem at that rope. And so I can do that, and I'll have two systems left over. So I'll draw out the two systems. A with some force F acting on it. So here I got the two ropes in block B. Here I've got block A, and so I'm treating those as my objects. And so let's focus on the one on the left first. So here there'll be some little part A is pulling up here. I'll call it a tension. Okay, so block A is pulling up on the rest of the system. And then the only other force acting would be gravity. And so I'll call this M1G, where M1 is the mass of this system. So this is what I'll call this system 1. And the mass here is what was 1 block, 2 ropes, so it's a mass of 1.5 G. I'm sorry, 1.5 kilograms. Let me And so what do? Well, we do our F equals ma on this system in the y direction, again, where it's M1A. And so I get tension minus M1G equals M1A. And I can go through and solve for that tension. That's what I'm trying to find. I get M1G plus M1A. And if I do this, again, pulling out the M1, I get G plus A. And when I plug that in, I got 19.2 newtons. So what's happening here is basically this tension has to be big enough to overcome the gravity of this system and to accelerate the system at 3.2 meters per second. Now I can also do it with this system over here, which I'll call system 2. And so there's a force upwards on this. There'll be the mass of AG acting down, and then there's this same tension, okay, from rope 1 that's pulling down. So there's 3 forces on this one right here. And so if I do my Fy equals M2A, so I'll call this system 2, so I get force minus that tension minus MAG equals MA acceleration. So mass 2 is just MA, it's the only object acting there. And if I take this and solve for the tension, what I come out with is I'll get the force minus MAG minus MA acceleration. And so we plug in our numbers. We know the force was 32 newtons. This is minus 1 kilogram. I'll just drop the kilogram just to make my life a little bit easier. And then minus 1 kilogram, and this is 3 meters per second squared. So if we take that and plug it into our calculator, we get 19.2 just as expected. So you can do it either way, and in my opinion, I think taking the bottom, okay, the bottom half, side 1, is actually, is better. Okay. Now the last thing that the book will do is it'll cut the rope sometimes at the halfway point of the rope. And the only thing that changes in that case is just like, for instance, doing it in side 1 is the mass of the rope. This part here would be cut in half.